Hi everyone, sorry we're starting a little bit late. My name is Rosemary and we'll be working on system science training on real-time sensors. We'll actually be looking at the AirBeams and the Atmotubes. We're not going to really end it all here. I wanted us to go outside and get a feel of what these sensors look like and how they work. Is that okay, or you want us to just wrap it up here? Cool. These are Atmotubes. Yeah, and then these are the AirBeam sensors. So the AirBeam is basically a wearable air monitor that maps and graphs and crowdsources air pollution exposures in real time through the Aircasting Android app, and it measures particulate matter of 2.5. What that simply means is that 2.5 means the aerodynamic diameter, which means that they are actually tiny particles, and we're really interested in this size of particulate matter because they can deposit deep into the lungs, and they've been associated with a lot of health effects, respiratory effects, cardiovascular effects, premature mortality, increased hospitalizations, low birth weight, stroke, a whole lot of diseases. And it's basically produced through industrial processes like a concrete block plant, and then through road transportation, basically diesel trucks, commuter traffic. And this is just reiterating what I just mentioned about the PM 2.5 that enters the body through the nose and the mouth when we breathe. And because they are tiny, they actually go down deep into the lungs and they remain there. And the major problem with particulate matter is that based on what kind of processes that produces it, you have chemicals adsorbed to it like lead. You have a lot of things adsorbed onto it. So it's not just the particles that are the problem, but whatever else could be adsorbed onto it. Like if it's from a concrete block plant, then we should be bothered about silica being together with those PM particulate matter, which causes a lot of adverse health effects. I'll walk us through I'll walk us through how it will work, but we'll still go outside. I have some printed out little instruction on how to do it, so that when we go out, we'll get to have a feel of it. But if you have an Android phone, the AirBeam basically works with an Android phone. So if you have your Android phone, I would like you to go to the Play Store and download the Aircasting app.
So if we have an iPhone, we cannot do it?
No.
Oh.
You can. This just works with the iPhone. Yeah. And this will basically be better out when we go outdoors and then have a feel of it. But how many Android devices do we have here? Okay, cool. So please, can we download Aircasting app? Or Vivek, do you think we should pair them in here, but the Bluetooth will be seeing a lot of these sensors close together? Yeah.
Is it Aircasting Live?
Aircasting app. This is actually what the logo should look like when you go on the Play Store. Oh, sorry, let me. So this is what you should see on Play Store before it's. I'm sorry.
I think it's because it's already installed.
Yes, it's already installed on my own phone. And okay, yeah. So when we go outside, we make use of it. And the AirBeam it has an interactive interface, and it has different sensors dashboard which shows different things. Basically, the AirBeam measures relative humidity, it measures temperature in Fahrenheit, and then it measures particulate matter in microgram per cubic meter, and it's interactive, so you get to play around with it. And right now it actually plots a graph of whatever it records the average of whatever it records every minute. So you can actually see the trend if wherever you are has an increased PM exposure, or if the PM exposure at that point in time also reduces. So it shows you the trend of, if you're looking at 30 minutes outdoors, so you can tell the trend.
This is, okay, it is correlated with the GPS.
Yes.
So it tells you where you are.
Yes, so that's on the back end. I can play around with it and actually get some heat maps to actually tell me what the PM was reading all around. So I get to play with it behind. That's behind the scene. That's what I do for fun. And
what are the other ones? I can't tell. There's yellow and white lettering.
okay, this is humidity. This is activity. This is heart rate, but we're not doing all of that. But we're just we're just interested in humidity, particulate matter, and then temperature.
It also has carbon monoxide. Is that what that is?
Yeah.
Is it CO gas?
Yes, carbon monoxide, but basically they updated the app. So right now what it measures is just particulate matter, relative humidity, and then temperature. So that's all you're going to see when we step outside.
Okay.
Do you know, maybe a little second.
No, go ahead.
Do you know if it corrects the particulate matter for relative humidity?
I don't know how that works, but based on what I read, it's kind of, it works through some light scattering method. And
Yes, so if you have, so typically when you measure particulate matter with a light source or light sensor, you need to correct them for relative humidity, because relative humidity makes the particles move quicker to the sensor. So my question was, do you know if it corrects, or do you have to correct afterwards?
I don't mess with it. I just pull down my Excel sheet and then run whatever I need to run. I don't.
But I haven't used this one, so I'm not familiar. But
Yeah, but these ones, yeah, they're good. These are AirBeam 2, so they're actually better than AirBeam 1, which is what we've been using. We just got these like 2 months ago.
And can you tell us how much volatile?
Dr. Wilson handles that. It's out of my pay grade, so he handles that, and he'll probably
300.
oh 300. Okay. But truly, I have no idea. And it actually plots a map to display where you, because basically when you're monitoring outdoors, because you're monitoring it's personal monitoring within your breeding zone, so you're basically walking around within an area, and then when you get back, you can actually plot the heat maps, and it shows you kind of, if you, I don't know how many of you know about the air quality index and the different colors and what it means. So based on the understanding of that air quality index, these differ and kind of tell you if the air quality at that point in time was okay or not.
Is there like a memory where you can actually look at those numbers, or you just get the map?
There's actually a map on the app, and then you can actually share whatever you've recorded off on the side. I'll show you how to do that when we get out. It's difficult talking about it, but it's easier when you actually show people what to do and how to do it. So it's a kind of, you can email it to yourself or whoever as an Excel file. It has, it's geolocated, so you have the longitude, you have the latitude, you have the particulate matter, you have everything right there, the time and everything. So it's easy for you to work with. If you need to also throw in GIS. I know I'm talking too much nonsense, but I'm sorry. I'm sorry. So it depends on how you want to play around with the data you've got. and what you want to throw into it. It's pretty awesome.
You know, the EPA approved, you know,
In reference to the federal reference monitor, it's not, but it's because of the work we do, the environmental justice work we do, and the community engagement we do. These are easier for a community to monitor, and based on, because how it works, this kind of monitors a personal exposure, but the federal monitor, maybe like some 20 kilometers away, just assumes that everybody is being exposed to the is being exposed to the same amount of particulate matter, the same amount of ozone, but this actually measures individual exposure, although within the community. So it kind of gives you a good idea of what happens relatively at that point in time. It may not be as good as the federal standard, but these have been tested and they have actually been shown to be correct. They may not be 100% correct, maybe 80, 85, which is okay for us to say that, okay, the air quality within this area has certain issues.
Now, how we use those too in our community. How we got around it, we work with the state regulatory agency who runs the federal reference. We co-located them with federal reference monitor, found out it was a sampling bias, and we created a coefficient to correct the sample. So we can compare our data that we collected to federal reference.
And what I was also going to say is EPA doesn't recognize these monitors, but they are encouraging people to use them so that they have more data, so that they can correlate them with the reference.
But there is an EPA compliant air monitor out there that's like two. It's about $100 each. I don't remember the name of it. I just know that it's out there. So I don't know if you're familiar with them.
Yeah, we're probably expecting another batch of monitors. That's the flow, which will monitor PM and VOCs all in one. Unlike now, we have different sensors for both. So we're expecting a new batch in June, and I get to play with some new toys. I'm excited. And then this is another crowd mapping that it shows based on, because we're not just the only ones using them, so we can actually look at a map based on other individuals who are also using them, and kind of look at the air quality and be able to tell where the air is actually bad. This is done through the back end when you play with it on the aircasting website. And then, like I mentioned, the new app now actually draws a graph showing you the trend for every minute, the average every minute. And then this is the Atmotube. It's a wearable and portable device that measures volatile organic compounds in real time through the air quality score. And it has an LED monitor. There's a light there that kind of alerts you when the air quality around you is unsafe. And why are we interested in VOCs? They've been associated with various adverse health effects, irritation, respiratory irritation, nose irritation, sensory effects, headaches, skin irritation, damage to the liver, kidneys and central nervous system, asthma and other respiratory effects. The Atmotube is relatively easy to use. It works on both the Android and the Apple device, and you just go to the Apple Play Store or the Google Play Store and you download the Atmotube, and it's easy to connect and you're up and going. These are just logistics for community members who want to kind of monitor within their community. For your data to be taken seriously, it needs to be done precisely at the same time. And if you're looking at different locations, you're starting at this. If you're doing like a 2-week monitoring, make sure that, for instance, if you start at 8:30 a.m. on Monday and you still want to monitor on Tuesday you're starting at the same 8:30, just to be consistent that with the data you have. Yes, please.
And I'm assuming this does the same thing, giving you Excel sheets.
Yes, yes. They both give you Excel sheet. But the tricky part about this one, on the Android device, it gives a Unix time which you actually have to Google and learn how to convert it for it to show you the date and the time. Yeah. But on
Do you mind going back one slide to the picture of, yeah, what it actually shows? So it's two.
okay, yes, this is the screen when it's connected and it's measuring. This is VOC. It measures VOC and CO together. This is humidity and then the temperature. Although it measures the temperature in centigrade.
What pollutant is that score for?
This is for the volatile organic compound that it's measuring.
Probably total view.
Yes, total VOC. It doesn't specify into styrene, toluene, and all of that. It's just total.
No, I know. That's part of the problem.
So how do you get a rating? I don't understand that.
We actually, for me and the work I do, I'm actually interested in the Excel sheets that I can download and play around with depending on what I'm looking at.
What you can do with total VOCs, which is not a lot, but it's like an indicator of some problem areas, and then you can bring your more sensitive or more specific instrument and do that specifically.
Mm-hmm. Yeah.
So in the data that you've seen though, I mean, it's only reading, in part per million, how often do you actually get readings that are significant? Does that make sense? I just feel like a lot.
In order for me not to be biased, I cannot tell if it is significant until I start running my correlation and ANOVA and all of that before I know if whatever I got is statistically significant for me to say, okay, this is what I found, and we found out that it makes sense.
Well, I guess how high readings have you actually seen?
Based on what I've done, I haven't really seen high readings with this, but the AirBeams give me much higher readings. Most times I see like a 0.7, a 0.6, so it's not really outrageously high, unlike this one that can give me like 70 once a truck or something passes, and I'm like, okay,
Yeah.
that's the reason why.
What is that, as to both of these, are they sampling continuously or do they just sample once a minute?
It depends on what you, okay, they're sampling continuously, but it depends on what the individual wants. If you feel that it's for 30 minutes, because wearing these around may not be as comfortable as wearing these around. These are easier to wear around and they're not obstructing you. I don't know if it makes sense. But carrying these around in your office and all of that, it's too obvious. So people might actually disturb your work or disturb whatever you're doing. So these are convenient. So we're kind of still looking for sensors that will measure PM that will be as small as this. So that way you can actually do personal monitoring of individuals from the beginning of their day until the end, and then kind of know what they're doing, if they are cooking, if they are commuting, and then you can link the readings you find to the activities that are going on at that point in time.
Does this one use spatial as well?
They don't do spatial, but if you want to add spatial to it, that means you're going to do GIS, because the Excel sheets are also geolocated. So you could, yes, both of them are. So if you want to throw in GIS, then they are both separate components that you put together to make work for you. Yeah. And then most times when we're out sampling, we actually conduct traffic counts, which is basically counting the cars that pass by, so that we can we can say or link some of these exposures to commuter traffic or industrial traffic, because as you're taking traffic, as you're counting traffic, you're also kind of taking note of what's happening around you, if there's construction going on, so that you don't just go and scare people and say that the air is bad. Meanwhile, it could be due to construction going on, or it could be like a garbage truck that passed and spiked up your reading. So those you also need to take into account. And it's basically counting the number of motor vehicles, including cars, buses, vans, trucks, that drive past during your sampling period. And you could either do it manually, which is recording it in a traffic count data sheet, or you use electronic counters to do that. Air pollution is a big issue, and that's why we're interested in it. We have indoor air pollution and outdoor air pollution, but the problem with indoor air pollution is that it's not regulated. There's no regulation on it, and you have a lot of things that could actually pollute your air indoors. But the outdoor air pollution is regulated and could be caused either naturally through volcanoes, wildfires, or through mobile sources such as aeroplanes, trucks, and buses. It could also be stationary, which include factories, power plants, and it could also be area sources, which are small residential sources like like residential heaters. Air quality affects our health and has been linked with a wide range of adverse health effects such as respiratory illnesses, cardiovascular illnesses, preterm birth weight, low birth weight, premature mortality, and some of these pollutants are short-lived in the atmosphere while others stay relatively for a long time. And it depends on its reactivity with other substances and tendencies for it to deposit in the surface. Like VOCs are really an issue because they could in the presence of sunlight, they also form bad ozone, which also causes problems to us. And these are influenced by weather conditions such as temperature, sunlight, precipitation, as well as the chemical compound. The air quality index is just a set of colors that tell us what the air quality in a location is all about. It could be good, moderate, unhealthy, healthy, and all of that, but they are, for each of these apps, they are calculated differently, but the EPA actually looks at the 24-hour average air quality. And the air quality index is important because it's used for reporting our daily air quality, and it focuses on health effects that you may experience within a few hours of breathing contaminated air, and it's calculated using the criteria air pollutant concentration. EPA regulates 6 criteria air pollutants under the National Ambient Air Quality Standards, which are ozone, particulate matter, carbon monoxide, nitrogen dioxide, sulfur dioxide, and then lead. The primary standards are designed to protect public health, especially sensitive population, and the secondary standards protect the public welfare, which includes the environment. Thank you. Any questions? These are 300, and I think these are like 100. I'm not too sure, but it's 100. Okay. So if you're ready, we can actually step out now.